Hello everyone, with October-November 24 Paper 2. Paper 2 AS level structural question. As we know, dear candidates, this paper is very important one from the very important paper or the core for the AS level chemistry exam, as it composed of some questions, and these questions are structural question and you can collect marks from it. This question or this paper, it composed from 60 marks, and these 60 marks are very easy to collect them totally, or at least not less than 50 marks from this paper. Okay, this paper is very important, as we said, and it composed of some question, depends on the contents, and all these question, it should be answered by your pencil or your pen. Don't use corrector. Don't touch these codes, are very important. Don't touch these codes. Okay, and you can use your calculator. You should show all your working and your appropriate units. This very important point. Don't just write your answer without showing your work. Here is very important to show your work and your calculation, as it gives you a chance to write what you know and what should you write, or to explain what you know. Okay, this paper, it depends on two things. The first one is just write the important and correct answer. Just write the correct answer. Okay, so the correct answer is very important to write it. Don't write or don't explain something you are not sure from it. Second point, you must show the keywords. Keywords here in this paper is very important. All keywords are very important. So in the question, if you're asking about something, you must mention for the keyword what this examiner, he need to see it in your paper to decide you already understood what he needs from you from this question. Okay, so the keywords here are very important, as we'll see in next incoming questions. Keywords are important in all these questions, so you have to mention for the most important keywords in the question. Let's start direct with the question number one. Question number one is saying vanadium and niobium and tantalum are metals in the same group of periodic table. The shorthand electronic configuration of vanadium in the ground state is argon. Then 3D it has 3 electrons, and 4s it has 2 electrons. State what is meant by the term ground state. Okay, so here, as we see, the first question is state what is the meant by the term of ground state. The question totally, it doesn't have any relation with the introduction, but he's asking about the ground state. Ground state of what? Of atom. So what is meant by ground state? As we know, the ground state or the natural state is the lowest energy state of atom, or not excited. Not excited, it means here the electrons in outer shell or in equivalence electrons, they don't have any more or less energy, or they didn't change their places. So what's the keyword we should write here? The lowest energy state of atom. If you show your examiner this keyword, he will consider it as correct. So here, what is meant by the term of ground state, it means here the energetical or the lowest energetical state of any atom. Okay, perfect. Next question is, let's use another one. Okay, show the electronic configuration of vanadium using the electrons in boxes notation. What's vanadium? Vanadium, as we know, is V, and it composed of how many electrons? Composed of 23 electrons. 23 electrons. Okay, and argon here, how many electrons? 18. So from 18 to 23, how many electrons we have? Of course, 5 electrons. 5 electrons, and this is 3D, and here is 4s. The 4s we should add here 2 electrons, and in 3D, how many electrons left from this 5? They are 3. We should put them here individually, not okay, and we can distribute them here in any suborbital shell, but they should be, the 3 electrons should be individual filling the suborbital shells here. Perfect. This question. Okay. Deduce the total number of electrons in the p subshells of vanadium atom. Perfect. So he's asking here about what? The total number of electrons in what? In B. What? Subshells. He said subshells. So all of B are considered in the configuration of vanadium. So we should write the configuration of vanadium again and see how many B's do we have. And according to the number of electrons in this subshells B, we can find how many electrons. Okay, let's write down here the configuration of vanadium, which is 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2. Next is, yes, 3d. How many? 3. So he's asking about what? Subshells B. Where are they? The first one is 6 electrons. Second one, it has also 6 electrons. 6 plus 6 equal how many electrons? 12 electrons. Do we have here any other B's? No, we don't have. Do we have B in 4? No, we don't have. So we have just 2 B's, 3B and 2B and 3B. Both of them, they have 6 electrons, and all of them, they should be 12 electrons. Okay. The question is, palladium was suggested to be or a name for a new element discovered in a mineral. Palladium was later found to be a mixture of niobium, which is Nb, and tantalum, Ta. Fine. Only the natural compounding or only one naturally occurring isotope exists for each of niobium and tantalum. What does he need here? He need the, this is a table. We need to complete it. This is the most easiest table. You can find it here in this paper, and you must find something like that. He's asking about the niobium number of electrons, and he gives you the relative isotopic mass. What is the number of protons here? From the table, we can find it's 41. That's it. Okay, number of neutrons. We know number of neutrons equal number of proton. Okay, number of or the atomic mass number minus number of proton, which is 93 minus 41. Okay, to give us 52. Like that. Okay, next is the number of proton in case of tantalum. Tantalum is 73, and here 181 minus 73 equal 1. Here is 108. What? Neutron. Here we have neutron, and here is neutron. 52 neutron, and here is 8 neutron. Define the relative isotopic mass. What is the relative isotopic mass? Okay, so here we have something is called relative mass or relative isotopic mass, and we have real mass. What's the difference between real mass and relative mass? Okay, real mass is a real mass for a substance or an object. This real mass is a real mass for an object. Okay, and this real mass, it has a unit like gram, kilogram, or something like. But the relative mass here, or any relative mass without unit. What is the relative mass we have here in our curriculum? We have first the relative atomic mass. Relative atomic mass. Relative atomic mass number, to find it, it's as this atom or this element, it has more than one isotope, so we should take the average between the number of isotopes according to their percentages, and this is the relative atomic mass. Okay, do we have here any unit? No, we don't have any unit. The second relative atomic mass, the relative mass, is the relative molecular mass. What is the relative molecular mass? Relative molecular mass is the total number of atomic mass for all of atoms in this compound. Is the total. For example, if we are talking about, for example, H2SO4, What is the relative atomic mass for H2SO4? 2 hydrogen multiplied by 1 plus 1 sulfur plus 4 oxygen. At the end it will be 98. 98, this is the total molecular mass for sulfuric acid. Do we have here any unit? No, we don't have any unit. Then the last one, which he's asking about, the relative isotopic mass. And here we should stop for 1 second. What's this relative isotopic mass? Relative isotopic mass is related to a specific or particular isotope. What is isotopes? Well, what are the isotopes? As we know, isotopes are, or some, we can say some elements, they have more than one atom. Okay, what's the difference between these atoms? They have the same proton number, okay, but different neutrons in each one. So these are isotopes. For example, we can find hydrogen 1, can find hydrogen 1, hydrogen 2, and hydrogen 3. What is the difference between them? Hydrogen 1, it has just one proton, it doesn't have any neutrons. Hydrogen 2, it has one proton and one neutrons. Hydrogen 3, it has one proton and 2 neutrons, and here it has just one proton. What is the difference here? The difference in the total or the atomic mass number for this hydrogen, okay, or the isotopic relative mass for this isotope. The first isotope, it has relative atomic mass 1. Second isotope, it has relative atomic mass 2. The relative atomic mass or relative isotopic mass for the hydrogen 3 is 3. So how can we detect it? It is a comparison between the particular or specific what isotope and 1/12 of carbon 12. Okay, so why 1/12? And here we should explain it. 1/12 from carbon 12, I mean all of isotopes, they are compared to detect it, or to detect this isotopic mass, we should compare it with something is a standard. What's the standard we should use? The standard we should use here is called carbon 12. Is the most stable atom. Okay, the most stable atom. So carbon 12, it has how many electron? It has how many proton? Carbon 12, it has 6 proton and 6 neutrons. 6 protons and 6 neutrons. Okay, so for example, let's start with hydrogen 1, hydrogen 2, and hydrogen 3. What is the relative atomic mass here? The relative isotopic mass for the first one. Hydrogen 1 is 1. If we compare it with 1, and we need to compare it with 1/12. So 1 here is 1 part from 1/12. Okay, so here is 1 part from over 12. This is the relative isotopic mass. Do we have unit here? No. In the second one, H2, it's 2 compared to 1/12. So 2 here is 2 parts from the 1/12, sorry, from the carbon 12. What about 3? It's 1 compared to 1/12, okay, from this carbon 3, sorry. Okay, so here this hydrogen is 3 parts from carbon, which is 1/12, and H2 is 2 parts. H1 is 1 part. If we take another example, for example, bromine 34 or bromine 35. What's the difference between them in relative isotopic mass? Bromine 34, if we compare it 34 to 1/12, okay, so 34, it has how many parts of 1/12? Yeah, it has how many parts? 34. So it's 34 relative isotope. So we are comparing our number, or the total number of proton and total number with neutrons, with how many 1/12 of carbon 12. The bromine 35 is related to 35. Okay, if we compare it with 1 over 12. So it has how many parts from 1 over 12? It has 35. So what is the relative isotopic mass? Is the relation, is because it's a relative, is a relation between the number in particular or specific isotope, is the relation between the total number of proton plus neutron, and compare this number with 1 over 12 of what? Of carbon. Carbon what? 12. Okay, why carbon 12? As carbon 12 is very stable element. Okay, next question is, a sample of palladium contains 90.9% by mass, okay, of niobium and 9.1 by mass of titanium. Calculate the theoretical relative atomic mass. This is the relative atomic mass which we have explained here before in that one, the relative atomic mass. And we said how can we explain it, or how can we define it? The relative isotopic mass is the total mass of all of isotopes, the total according to their percentages in nature. Okay, according to these percentages we can find, or we can calculate the relative atomic mass for this element. So the palladium, we need to find the relative atomic mass. What is the first one? The first one, which is niobium, it has its percent is 90.9. okay, so 90.9 like that over 100. This is the percent multiplied by the, okay, look, he said here, look at the question. He said, based on this data and table 1.1, give your answer. So if he mentioned for any given information, you must use it. The examiner, if he mentioned for something in the paper, you must use it, like the table point 1.1. Where is the table point 1.1? Here's this table. What does this table has? It has the relative isotopic mass. As we are talking about different isotopes, so we should use this mass in our calculation. We should use this mass in our calculation, which is 92.91, and here 180.95. So the first one is 92.91. So 92.91. Okay, plus what? Plus the 9.1 over 100 multiplied by the 180 point from the periodic table 0.95. Okay, at the end we'll find us here 100.7. okay, so the real answer here is 100.7. This is the theoretical relative atomic mass of palladium. Do we have unit here? No, we don't have unit. Why? Because this is a relative atomic mass. We don't have unit. But if we are talking about real mass for a specific object or a specific substance, we can find it from the form of the number of moles, okay, multiplied by the relative atomic mass number to find the mass. Okay, and in that time, this mass or this real mass, it has a unit, and this unit, it should be in gram or kilogram. Perfect. Question number 2. Oxygen is a group 16 element. Okay, write the equation for following reactions: sodium and oxygen, and sulfur and oxygen. So he is talking about the group number 16. What do we have here? We have sodium. What is sodium in A? We need to write the equation between sodium and oxygen. Okay, oxygen, now we wrote the elements. How can we make our balance, or how can we adjust our equation? The equation, it must show us how many points. Okay, the equation should show us the first one, number or the type of atoms. What else? Number of atoms. Okay, the number of atoms here, I mean the balancing equation, and the physical state. Okay, first, here's the sodium. If it reacted with oxygen here, can we write just one oxygen? No, we cannot. Why? Because oxygen is non-metal and it must be O2. Okay, O2 is oxygen. If it reacted with sodium, H1O, it needs how many sodium according to the oxidation number or the common oxidation number for each one? Oxygen, we know it's -2. So each one oxygen needs how many sodium? 2. So how many sodium should use? 4. So 4 sodiums, if they react with oxygen, they will give us here the what? How many sodium do you have? Or what's the result? So result it should be Na2O, like that. So how many sodium you use? 4. So it's 2 multiplied by 2 give me 4, and 2 Na2O. This is the sodium oxide, and this is the first question. Okay, perfect. Second one, sulfur and oxygen. What is sulfur and oxygen? Sulfur is S. If it reacted with oxygen, oxygen 2 is O2, and S is sulfur, so it should be, give us here, SO2. Yes, perfect. Okay, you will say now sulfur is like that. Yeah, it is SO2, sulfur dioxide gas. And here is gas, sulfur is solid, gas, solid. The question is the maximum oxidation state of the period 3 elements in their oxides varies across the period 3. State and explain the variation. Of course, in the period number 3, like sodium, magnesium, and aluminium, silicon, all the can react with oxygen, and the oxidation number should increase. So here's the change. We should say it increase from left to right side. Okay, for example, sodium, it's positive 1, and magnesium positive 2, aluminium is positive 3. So it's increasing. Why it should increase? As we are increasing the number of equivalents, or the number of valence electrons, as we are increasing the number of valence electrons, which should lose to react with oxygen, so the oxidation number also should increase. So this increase is due to the number of valence electrons will increase through the period. Okay, what the valence electrons? The valence electrons which should this element lose to react with oxygen. Okay, so by losing more electrons, it means the oxidation number should increase. Okay, increase, so the oxidation number in oxidation state should increase. Okay, what the valence electron? The number of electrons which should got lost by the element to react with oxygen. Of course, this is not the answer. What is the answer? Answer just increase due to, the answer is just increase. Okay, due to what? Due to increase the number of electrons, increase. Why? The number of valence electron increases. Okay, if the number of electrons increases, it means the oxidation number, it will increase. So the result, or the answer is increases as the valence electron which can be used increase, so it will lead to increase the oxidation number. The question B is about the water and the reaction of water with the period 3 oxides. Period 3 oxides, as we know, period 3, it has metal and non-metal, and between metal and non-metal we have aluminium. Aluminium is amphoteric oxide. So here we have, in period 3, we have sodium, we have magnesium, then we have aluminium. Okay, then we have, after aluminium, silicon, phosphorus, sulfur, and chlorine. Okay, the first two are metal. So oxides of metals, we know it gives us a basic. If it reacted with water, it should give us a base. So it gives me magnesium hydroxide. Okay, so what is the period 3 oxide here? It should be MgO. How can we know it's MgO? Because it gives me here the magnesium, and magnesium, it's a positive 2, it should react with one oxygen, so it will be MgO. The pH of this base, because it's a strong base, it's between 8 up till, maybe it's between 8 and more than or equal the pH, okay, 12. So it's between 8 and 12, as we consider it as a strong base. Okay, this is sodium and magnesium. Aluminium is amphoteric oxide, Al2O3 is amphoteric oxide, and water insoluble. Water insoluble, but it can react with base and acid, so it can react as acid and base, but it cannot dissolve in water. Silicon silicon here is a starting of non-metal oxide. Silicon is non-metal oxide, but it's water insoluble. But if it reacted, it will react as an acid. Then phosphorus and silicon, chlorine, they are reacting as acid, as they are, the oxides here are acidic oxide. Okay, phosphorus, if it reacted with H2O, the phosphorus, if it reacted with H2O, the reaction will be, for example, B4O10. Okay, if it reacted with H2O, should react to 6H2O to give us 4H3BO4. This is acid. So here, if it gives us here this H3PO4 phosphoric acid, the phosphoric acid is a very strong acid. Its pH is between 1 up till 4 or 3.5. This is pH. So the results now, or the correct answers here, this is MgO, and the result of reaction of phosphorus with water gives us H3PO4 as an acid. The question is, write an equation for the reaction of CH3CN with H2O. This is a hydrolysis of methyl nitrile. Okay, methyl nitrile, we have two kinds of hydrolysis for nitrile. It may happen in acidic condition or basic condition. Here in acidic condition, and it happens in it should happen in two steps. The first one is the hydrolysis of the nitrile to give us an amide. After that, this amide got more hydrolyzed by water to give us acetic acid. So we should memorize it like that. To write the two steps here, we can write them here. The first step is CH3CN plus H2O should give us an amide with CH3C double bond O CN. NH2. Okay, this is what? This is amide. This amide, after or under more hydrolyzing by H2O, it should give us this second step, should give us the acid, which is CH3C double bond OH. This is the acetic acid plus NH3. So what should we write here? We should write the result, which is CH3C double bond OH plus NH3, as we started with one N. So here we have just one ammonia, and this is the number of acid here, this is number of water, and the overall reaction telling us the reaction between methyl nitrile and 2H2O, which would choose here 2H2O, in presence of acid. In presence of acid, it will give us the acetic acid plus NH4. Okay, NH4, positive one. Okay, this is amide. The question is, draw the structure of the two alcohols formed in reaction shown in this equation. The equation is C3H6. This is alkene with water in presence of acid. Okay, this is the hydration of alkene with water in presence of acid. As we know here, alkene, as it has double bond, so it has density of electron, and working as a nucleophile, it can attack and accept, as here we have negative charge, accept proton from the acidic media, okay, from H3PO4, as we have here H positive. It got accepted by reacted with the double bond and break it down and give us here a carbocation. So it should give us CH3CH, and here one bond, and here we have CH2. So here we have two options. This hydrogen can enter the first carbon or second carbon. If the hydrogen enter this carbon, so in this time we will find this is carbocation, it will give us a carbocation with positive charge to react with OH from water. If the hydrogen enter the second carbon, so OH will attack the first carbon. So the structure of the first one, if the hydrogen reacted or attacked the first carbon, if the hydrogen entered this first carbon, Okay, so OH, it will be here in the middle to give us CH3, C, here we have OH, and H, and here we have CH3. Okay, this is the first structure. Second structure, it will be like that, CH3, CH2, here we have CH2, and OH will attack the first carbon to give us here the second structure, alcohol. The first one, this alcohol is secondary alcohol, and the first one, the second one is primary alcohol. The secondary alcohol, and that one is primary alcohol. The question is explain why alcohol are less acidic than water. So we have here a comparison between alcohol and water. Water is HOH, okay, and alcohol is, for example, ROH. Which one is more acidic? Water is more acidic than alcohol. Why? Because here we have R, and this group is donating group, so it has inductive effect to increase the negative charge here in this bond, making the releasing or making here more stable bond between the R and oxygen, and giving the oxygen more stability and more negativity, which attracting the hydrogen toward itself more than the water. So here, due to the inductive effect of R as a donating electron, so it making the alcohol releasing or donating the hydrogen or this proton is difficult, or a little bit difficult than in case of water. So here, as we have here R, it has inductive effect, which give the bond between the alkyl group, giving the bond between O and H more stability, okay, to decrease the acidity chance. That's not here in water. The question is, in this figure 2.1 shows the boiling points of H2O and other group 16 hydride. The first question, explain the trend in the boiling points of the group 16 hydrides H2S to H2TE. Okay, so we need to explain why it got increased by this way. As we know, from up to down, the number of electrons increase. So as we increase the number of electrons from H2S to TE, the number of electron increase, also the van der Waals forces between the molecules got increased, which led to increase the boiling point. So it's due to the increased number of electrons, which led to increase the van der Waals forces between molecule. Okay, this is the answer. Explain why the boiling point of H2O is much higher than that of H2S. Of course, H2O, HOH, HOH, here we have a different kind of intermolecular forces, which is hydrogen bond. So here, in case of water, we can find another bond. This bond is called hydrogen bond between H and oxygen, making another attraction force, or a higher, stronger, or more stronger attraction force between the molecules like H2O and H2O, and this bond is called hydrogen bond. We cannot find it in H2S. So the main reason here of boiling point of water is more higher than H2S is the presence of hydrogen bond in case of H2O and not in H2S.